one direction is not equaling the slope from other directions. So the derivative at that minimum point is undefined. So I do have a minimum point, but it's undefined. I would think that it's like going down to negative infinity, except that just graphically it's stopping there. And let's see, cosine, you know, is going to, yeah, so I mean the reason why it's actually coming to some point, so like the limit of this as x goes, as x and y both go to 0, the limit of this is not heading off to infinity or anything, because cosine is going to be bounded, and x is going to 0, so your numerator is bounded, and my denominator is going to 0. So that's why it is actually converging to some point, but it's doing so in creating a sharp point, and so we do have a minimum there, but it's undefined. So right off the bat, this beginning example is a good one graphically to look at, but in terms of mechanically working through it, it's not a good one to work through mechanically to get that minimum. If I do remember right, though, there are some clever ways to look at the z sub double x and z sub double y to verify whether or not we have a ring of maximums or a ring of minimums. So I do want to look at that before we leave this problem and go on to the next one. But I'm sorry, Robert or somebody had a question?
No, I was just saying, like, the point's not undefined, it's just the slope.
Yeah, the function's not under, right. So that's another reason why there is a minimum there, it exists, because the function itself exists, but the derivative is undefined. So the derivative being undefined is being supported by the fact that when I flip it over, you see that sharp point, and we know derivatives don't exist where you have sharp points, because basically the slope coming from this direction is a different value than the slope coming from some other direction. All right, if we, before I leave it, I just want to say, I thought I remembered there was a kind of a clever way to look at the factoring so that you could tell that you had a ring of maximums or a ring of minimums. So before I erase everything, I just wanted to look at that before we went on. So if we know that x squared plus y squared equals some odd multiple of pi over 2 squared, then sine of an odd multiple of pi over 2 is either going to be plus or minus 1. But what is true about cosine of any odd multiple of pi over 2?
0.
It's going to be 0. So at points where this is equal to an odd multiple of pi over 2, this term ends up being 0, this term ends up being 0, that term ends up being 0. And then I'm left with this, okay? So I get x squared, y squared, plus y squared, sine squared of... You know what, that's going to make it, yeah, so that'll make it always positive, and if z is, if this is always positive, again, it's not, it does need to be geometrically proven, and it's not easy to see, but this is always bigger in value than this when f sub double x and f sub double y are of the same sign. Okay, and that's why I'm able to just look at the one direction. Okay, so if we know this part's always positive, then, and we consider this, okay? Then that's positive, so I know I have mins and maxes, so then it's a matter of determining whether it's a min or a max. So, I have z sub double x still on the board. What, Robert?
On that bottom formula there, okay,